All right, so we're going to do a few sections on just figuring out probability. And the first section, we're going to talk about representing our sample space because we need to figure out like how many possible outcomes. So one way to do this is to make a tree diagram. So we have this situation, one red token and one black token are placed in a bag. A token is drawn and the color is recorded. And then it is returned to the bag and a second draw is made. Represent the sample space for this experiment. So I have something, I don't know what happened, but I know that they either got a red or a black on the first draw. And then they put that back in, and if they got the red, they could have either got red or black on the second draw, or if they got black, they could have gotten red or black on the second draw. So that is our outcome. So if I had this, they would have gotten red, red. If they did this way through the branch, they would have got red, then black. Here, if they did black, then red. And on this one, they would have gotten black and black. So we see all of the outcomes, possible outcomes. This is second draw, I should have put that up there. There's 4 possible outcomes: red, 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 black, black, red, black, black, and those are all different outcomes. And so this would be considered 2 stage because there's this first stage and then our second stage. So one yellow. So I would pause the video, try this one. It's pretty much the same thing, just a couple different colors, and see if you understand that tree diagram. All right, let's look at it where we have multiple stages, because that, so a chef salad at a local restaurant comes with a choice of French, ranch, or blue cheese dressings, and then you have the choice of cheese, turkey, and eggs. So this is going to be 4 stage. Let's look at it. So I could have done French, ranch, or blue cheese. So there's my first stage. That I picked which one of those that I had. And then we have the cheese stage. So I have cheese or no cheese. Each one of these, could have gotten a cheese or no cheese. So there's stage 2. And then from there, I could have chosen to get, I probably should have made this bigger, turkey or no turkey. And then with each of those, I could have then chose eggs or no eggs. Oh, I wish I would have made myself more room. And so forth. So each of these would then have that egg or no egg option. So then I could have French, cheese, turkey, egg, French, cheese, no turkey, should I have that the T? And I have all of these different stages. So here's stage 1, stage 2, stage 3, and stage 4. So notice we have the choices of our dressings, so that's stage 1, and then the choice of cheese, stage 2, turkeys, eggs, for each one. I'm going to put it on here so that we can have a little bit more space to do this whole thing. It's French, ranch, or blue cheese, and then we have cheese or no cheese. And then each of those could have turkey or no turkey. And then each of those could have egg or no egg. And then we could go through and write out each then possible outcome. But we can see that those all of each one. So I could have French cheese, turkey, egg, French cheese, no turkey, or French cheese, turkey, no egg, French cheese, no turkey, egg, French cheese, no turkey, no egg, and then so forth. So there'd be so many different ones, but there's a lot of different possibilities for each one. So if I think about this one, we have in the bleachers at a major league dog or game, you can purchase a hot dog, bratwurst, or tofu dog. This comes with optional choices of ketchup, mustard, onions, or relish. So this would be how many stages are these? So we have the stage of the type of dog. Then you would have ketchup or no ketchup stage, the mustard or no mustard stage, the onions or no onions stage, and the relish or no relish stage. So you'd have 1, 2, 3, 4, 5 different stages, which we can see that then I could come up with if I kept doing these tree diagrams so I could figure out how many total possibilities there are. I could have so many at the end because we saw even just with this one we had so many at the end. 24, and we can't just keep making tree diagrams because obviously I run out of space. So we have this thing that's called the counting principle. So if you take the number of possible outcomes in the first stage, the number of possible outcomes in the second stage, and so forth with each stage, and you multiply each of them, that's going to give you the total number of possible outcomes without having to make that diagram. So that's what we could do here with this. New cars are available with a wide selection of options for the consumer. One option is chosen from each category shown. How many different options are there? So according to the fundamental counting principle, then I have 11 different exteriors. So I do 11 times 7 with a dot, times 5 different seat materials, times 3, times 6, times 4, times 3. And if I multiply all of those, that will give us the total number of possible outcomes that I could have for cars, different cars. And you see it's 83,160 total possible outcomes with these car options. All right, so if you have any questions, let me know.